This is the Introduction to Advanced Algebra 2. I'm Mr. Stark. We're wrapping up topic 5, which is all about solving equations graphically, numerically, and most importantly, algebraically. And we're about to conquer lesson 5b, solving quadratic equations. We'll also solve an absolute value equation. You can follow along using this document and be sure to have your TI-84 graphing calculator handy. Here we go. Solving quadratic equations using the quadratic formula. Are you ready for it? Here it comes. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. When we use that formula properly, we end up with two solutions to the quadratic equation. And when those solutions are real, meaning we're not taking the square root of a negative number, then those solutions are the x-intercepts of the graph of the quadratic equation. Let's use the formula for this example. Solve 2x squared plus 3x minus 5 equals 0. This quadratic equation is in standard form, which is ax squared plus bx plus c equals 0. So the a value is 2, the b value is 3, and the c value is negative 5. Applying the formula, we get x equals negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 5. All of that divided by 2 times 2. Most of our work is spent dealing with what's inside the square root. So let's keep that stuff straight. The next step is negative 3 plus or minus the square root of 9 plus 40. Because 4 times 2 times 5 is 40, and the two negatives become positive. All of that divided by 4. That's all equal to negative 3 plus or minus square root of 49 divided by 4. And since 49 is a perfect square, we have negative 3 plus or minus 7 divided by 4. After we find the solutions, I'll give you some tips on how to deal with square roots of numbers that are not perfect squares. Now we can split that up into two parts. We have negative 3 plus 7 divided by 4 and negative 3 minus 7 divided by 4. And if we do those calculations, we get x equals 1 and x equals negative 5 halves, or negative 2.5. In a moment, we'll solve the same equation numerically on your calculator, but before we do that, I want to share those tips with you that I promised earlier. Let's say you got the square root of 80 instead of a perfect square like 16, 25, 36, 49, 64, 81, 100, and so on. The goal is to simplify the square root. So we need to think about what is the largest perfect square that we can factor out of 80. The official answer is 16 because 16 times 5 is 80. But what if you just said 4? Square root of 80 is equal to square root of 4 times the square root of 20. Then you look at that square root of 20 and think, oh, actually, I could take another square root of 4 out of there. So therefore, we have the square root of 4 times the square root of 4 times the square root of 5, which is equal to 2 times root 5, which is 4 root 5. Then let's say one of our steps was, 8 plus 4 root 5 divided by 4. Then we could factor out a 4 out of all three of those terms. And the answer becomes 2 plus or minus root 5. Now let's solve the same equation numerically with tables on the TI-84 calculator. The two menu options that we'll choose are Table Set, which is second window, and the table, which is second graph. You can follow along using your graphing calculator. So I turn my calculator on and I'm going to y equals to enter that function. And that function once again is 2x squared plus 3x minus 5. So we don't put that z equals 0 in there because that's what we're doing on the calculator. So we're finding out when it's 0. And then we'll press the second table set or second window And we'll change the table start, where we start, to 0. And the delta table, the change in the x values, is 1. And I chose that because one of our solutions is a whole number, an integer. So second graph gives us our table. And then notice how the x values start at 0 and go up by 1. So delta table is 1. And I could go up and down on that table. And then I see that the y value corresponding to 1 is 0. That's because the solution that we found using the quadratic formula was x equals 1. And notice how the numbers around 0 go from negative to positive. And then we could go up to find the other solution, which was negative 5/2, but we don't see the 0 because our delta table is 1. But we know that it's in between 4 and negative 3, because if the graph is above the x-axis, 4, then negative 3, the 0 must be in between. So we'll go back to our table set, change this to 0, delta table is 0.5. Then we press second graph to go back to the table so that we could see that other value. So you see how the x values change by 1/2 now? And then we go up, 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 and we see that at negative 2.5, there's a 0. Aha! It's kind of like what we expected, but also we knew that the solution was negative 2.5. Okay, so we saw both of those zeros, and if we didn't know what those zeros are, we could have found them anyways. But I pressed zoom 6 here so that we could see the graph, and we could actually see where the x-intercepts are, which are the solutions using the quadratic formula, and the table. So I could go to the left and see that one of the solutions is negative 2.5, and go to the right, and I could see that one of the solutions is 1. And I could confirm that using the second trace calc feature, finding the zeros again. Okay, that's it. That's how to use the table. And you could start with that, or do that after you do the algebra, or after everything. So we have the graphical approach, the algebraic approach, and the numerical approach. The last thing we'll do is solve using intersection points on a graphing calculator. Really what we're trying to do is find out when two functions are equal. So if you look at the example, it says solve the absolute value of 2x minus 1 equals 6 using the intersect feature. We can think of the left side of the equation as one function and the right side of the equation as another function. But before we plug that into the calculator, let's solve it by hand. This equation results in two different equations. One is 2x minus 1 is equal to 6. The other one is 2x minus 1 equals negative 6. The equation on the right is allowing for the possibility that the expression 2x minus 1 is indeed a negative number, negative 6. And then when you take the absolute value of it, you get 6. That's why we have those two possibilities. So if we solve the left equation, we get 2x equals 7 divided by 2, and you get x equals 3.5. Solving the right equation, we get 2x equals negative 5, because negative 6 plus 1 is negative 5. Then we divide by 2, and we get x equals negative 2.5. So x equals 3.5 and negative 2.5 are the solutions to this equation. Now we'll follow the steps on the left to verify those solutions using the intersect feature on the TI-84. Let's check it out. So I got my handy dandy calculator on, and I'm going to enter these two sides of the equation. So y equals, and to enter the absolute value, we press math, then arrow right to num, and then enter on the abs function. Enter 2x minus 1, and then that's it for y1. And then go down to y2, and we'll only enter 6. Then we press zoom 6 for a standard window so that we can see what's going on. And if we needed to, we could adjust the window, but it looks pretty good to me. So then we'll press second trace the Calculate menu and choose 5 for intersect. We're trying to find the intersection of these two functions, which we already know the answer to. It asks you a question. What's the first curve? And that just means the equation or the graph. Press enter, and then it automatically takes you to the second one. And then you could press enter. Then we arrow towards the solution. You don't have to be right on it, but you press enter. And then it tells you the intersection, -2.5, 6. Hey, that's one of our answers. We already found that solution. Let's do it again. 5 for intersect, and we're expecting 3.5. So what I like to do is arrow right first, away from the intersection. So I know I'm on the blue graph. Press enter. And then it bounces to the other one automatically. Press enter. And then move towards the intersection point. As long as you're closer to the intersection point that you want than the other one, it'll find that one for you. So we get 3.5 as the other one, and that's exactly what we found algebraically. So there you go. It's pretty cool. So the functions get more complicated as we go forward in the course, but we have the same tools that we could use throughout. We can solve algebraically and then confirm it numerically or graphically. That's the end of lesson 5B, solving quadratic equations. Thank you for nerding out with me on the TI-84 graphing calculator. I hope you'll join me for another nerd out session in the future. Thanks for watching, and let me know if you have a question. See you next time.